Okay, so try that one. So we're doing homework number 10, problem number 1, part C. The GCD, or GCF, same thing. GCF, GCD, it's all the same thing. Greatest common divisor or factor, because remember, divisor and factor are synonymous. So those mean the same thing. GCF, GCD, whatever. So find all the factors of 8. I got all the numbers, all the divisors of 8. Now 88. So go over on the side, find all the divisors of 88. So that means you take the square root of 88. I have no idea. What's the square root of 88? 9 something. Okay, 9 something. So that means we only 9.3. So we only need to check up to 9. So start with 1. 1 times 88. 2 times 44. Just use your calculator. Divide by 3. Divide by 4. 3 doesn't go, does it? So then 4 times 22. 5 doesn't go. 6 doesn't go. 7 doesn't go. 8 times 11, and that's it, huh? Because the next one will be 9, and that doesn't go, and so as far as we need to go. So write those out, put them in order from low to high, because you're trying to see the what they have in common, the intersection. So 1, 2, 4, 8, and by the way, you can do the order. They just go down this way and back up that way, don't they? From low to high, like that. This is kind of nice and orderly. 11, 22, 44, 88. This out of the way here. All right, and then the third one, the 64. So come up here, find all divisors, all factors, same thing, of 64. What are all the things? Let me give you a second, try that one. Find all the things, and then when you list them all out, find the intersection. I didn't do the LCM, though, yesterday, or Wednesday, right? So I haven't done any LCM, right? So we'll definitely do the LCM. So I really didn't even finish part A. All right, so for 64, square root of 64 is 8. So 8's as far as we need to check, and then they'll start repeating. So 1 times 64, 2 times 32. 3 doesn't work. You can try it in your calculator. It doesn't go. 4 times 16. 5 doesn't work. 6 doesn't work. 7 doesn't work. 8 times 8. So there we go. So go from low to high like that. So 1, 2, 4, 8, 16. We don't list the 8 twice. 32, 64. Okay. So there we have all the factors, all the divisors. Now, what we want to list is the common factors or common divisors. That's why we call it intersection, because we're basically saying those are 3 collections. What is their overlap? What's their intersection? What do they all have the same? Looks like it's just 1, 2, 4, 8. Pretty obvious, huh? So 1, 2, 4, 8 that's why we call this the intersection of sets method, because in the end we're intersecting those sets. That makes sense when I'm saying intersection, right? What they have in common, what they overlap. So they all have 1, 2, 4, and 8 as common factors or common divisors. So then, having done all that, what was the original question? The GCD. What's the greatest among the common divisors or factors? The greatest is 8. So it's 8. 8 and we're done. So 8 is the biggest number that would that be? 8 is the biggest number that divides evenly into 8, 88, and 64. You might feel like, boy, I knew that without doing all that crazy work. That's a lot, and that's fine. If you can do it, quicker, you can just tell. Feel free to do that. Use a calculator. 8, you could probably see from the beginning. 8's the biggest number that goes in. There are harder ones, though, I'll show you. And there's a better method. This really isn't the best method. This is kind of tedious. There's a quicker method that's actually more powerful than this. But yeah, you could maybe even just see the answer on that one. That good so far? Let's do the LCM now. Same, we're still on part C. So now 1C, we want to do the LCM, which is the same as LCD, least common multiple, least common denominator, whatever. Same thing. Same 3 numbers, 8, 88, 64. 888, 64. So by intersection of sets again, so we're going to be listing sets. Intersection of sets. Okay, so this is a little different. Now, what are we going to do? So I'm going to list the multiples of 8 first off. So what do we mean by multiples? We mean 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5, 8 times 6, 8 times 7, etc. So this is going to be totally calculator. You wouldn't want to do this by hand because you're going to get really big. So you're just going to take your calculator and just go 8 times 1, 2, 3, 4, and just write a whole bunch of them. So even more than that. So I'm going to write 8, 16, 24, 32, 40, 48, 6 times 8, 7 times 8, 56, 8 times 8, 64, 9 times 8, 72. I'm going to write that a little neater. 9 times 8, where was that? 9 times 8, 10 times 8, 80, 11 times 8, 88, 12 times 8, 96, 13 times 8, I don't know, 80, 12, 104? Thank you. 104, okay. Except now you wonder, well, how far do we go? Well, you'll see. Just do a bunch of them, and then let's do the next one now. Now we want a whole bunch, anyway, of multiples of 88. So we mean like 88 times 1, 88 times 2, 88 times 3. Now, we're not going to go far here. 88 times 1 is 88. 88 times 2 is already too big for me. 160 and 16. Is it 196? 176? Okay, thanks. 176, and then times 3, 240 and 24, 264, I think. Right? Anyway, that's probably enough. I just did times 1, 2, and 3 there. Okay, and now do the next one, which is the last one, 64. Same thing, 64 times 1, 64 times 2, 64 times 3. So that'd be 64 times 2 is 126, right? Times 3 is 180, 192. Uh-oh. Oh, did I mess up? 128? Oh, thanks. Times 4 is 24252. 256. I keep trying to guess here. And then another one, whatever that would be. 320. Right? 320. Now what? Well, let's keep going. What are we looking for here? We're looking for the first one they have in common. Like, we want a number that's in all 3 lists. This is an awful problem. Yeah, this is terrible. All right, I'm going to keep going. I don't see any number. I'm just looking at these last 2 lists, and I don't see any match here. So I got to keep going. So what is it? 64? 1, 2, 3, 4, 5. 64 times 6. What's that? 360 and 24. Is it 384? Yeah. And then 64 again. I don't know. Somebody got the next one for me. Is it? 440. Is it 440? 448. Okay, thank you. 448. We got to keep going. Yeah, I think it was 7. So then 64 times 8. What's next? I know this is a terrible method. I have a way better method coming. What's the next one? 512. And then 576. And 1, 2, 3, 4, 5, 6, 7, 8, 9. I know where. Two more and we'll have it. 640. Is that the next one? No, that's 2 down the line, isn't it? I think that's 2. Oh, no, you're right. And then 706. Is that the next one? No, 704. 704. Okay, I think that's going to be our magic player. You know why I'm saying that's because 64 times 11 is going to do it, because I know this 88 has an 11. Anyway, you'll see. Let's keep going. So now I got to go back. So this is a terrible method. So you got to go back to these other ones, and you got to do more. In fact, I'm going to have to do more on this 88 list here. Back to the 88. So it was 88, and let's just crank. Just have them real quick. Let's crank them out. What's 88 times 2? 166. 196. What's 88 times 3? 240. 264?
No, it was 176.
Oh, man. I keep trying to do this by hand. All right. 176. What's the next one?
264.
264. Okay, keep going until we get 704. Can you tell me? 352?
440.
440.
528.
528.
616.
What is it?
616.
616? Okay.
704.
Oh, there it is. Boom, boom, 704. Now, is 704 in the top list? Well, yeah, way down the line. How do I know it is going to be? Well, because 88 had it, which is 11 eighths. So 8's going to have it like crazy down the line.
88.
Is that what it is? 8 times 88?
Uh-huh.
8 times 88? Oh, that's terrible. So, yeah, sorry, this is a really lousy method. So if you kept going on the 8 list, you would find the number 704 way down the line when you did 8 times 88. That would be, so you don't have to list them all. You just, that's going to be the first number. That's going to be the lowest number among the multiples they have in common. Is that making sense? Right? Because these are all their multiples, right? These are them times 1, 2, 3, 4, 5, 6, etc. And so among these lists, this 704 is the first one, right? Certainly with the last two lists, it's the first number these two have in common, right? They would have more. If you kept going, who wants to keep going? But if you kept going, you would find more things they have in common. We'll do this on an easier one, and it'll make sense. So anyway, so the answer then, the lowest of the common multiples, the least common multiple, the lowest number that they have in common is 704. That's the lowest number that you would find in all three lists. All right, so that's pretty terrible. Questions on that? Does that make sense? If we have time, here's a good way, as that example clearly showed. So let's do D. So 1D says, let's start with the GCD of 2 and 9. So find the GCD of 2 and 9 by this same terrible method, intersection of sets. So then we'll go on, I'll show you some way better methods. There's many of them. So list out, so you want to list all divisors of 2. And then you want to list all divisors of 9. What are all the things that go into 2?
1 and 2.
Yeah, 1 and 2. It's kind of ridiculous, huh? There's nothing else that goes into. And what are all the things that go into 9? 1, 3, and 9. You can probably just do it off the top of your head. If you want to do 9 more formally, you could say, 1 times 9 and 3 times 3. There you go. So anyway, 1, 3, and 9. So then what is the greatest they have in common? Yeah, what's the only they have in common? 1. Yeah, 1 is the only number that divides into 2 and 9, isn't it? So that's their greatest common divisor. Greatest common divisor is just 1. Let's do the LCM for them now. Okay, so now come down here. So let's do the second part of D, and let's find the LCM for 2 and 9. So that means list the multiples of 2, and then below it list the multiples of 9. Until you find a number they have in common, you probably already know what the answer is. In a minute, we'll do hard ones that you won't know the answer, but the method will actually be helpful, and it'll get you the answer easily on a very hard problem. Right now, this method makes easy problems hard. So it's the worst. All right, so what are the multiples of 2? So we just start with, again, it just means 2 times 1, 2 times 2, 2 times 3, etc. So it'd be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, etc. Right? Those are multiples, times 1, 2, 3, 4, 5. And then what are the multiples of 9? 9, 18, 27, 36, 45, 54, ... Okay, do you see any numbers they have in common? 18. Is there any other numbers they have in common? Well, if I kept going, I didn't go far enough. I just want to show you that there are other ones. If I kept going with this 26, 28, 30, 32, 34, 36. They would also have 36 in common and other things down the line. right? 54, you can tell 54 would end up being in both lists, huh? So what's the lowest? So they do have more than one common multiple, don't they? They actually infinite. They go on and on. So what's the lowest among the common multiples? It's the 18, huh? So 18 is the answer. It's the lowest among the common multiples, which you probably already knew by just multiplying them together in the first place, right? 2 times 9 is 18. That's the common denominator. If you were doing fractions, you know, adding 1/9 and 1/2, the common denominator would be 18, wouldn't it? That's the lowest number that 2 and 9 go into. So you see the difference between what we're finding. Greatest common divisor is the biggest number that goes into 2 and 9. It's a tinier number than them, but it's the biggest among the tiny numbers that go into 2 and 9. And an 18 is the smallest among the big numbers that 2 and 9 go into. Do you get the idea? It's like containers, right? And a GCD fits into 2 and 9. They're the containers. And then LCM is the other way around. We want a big container that 2 and 9 fit into. And that's 18. Get the idea? We want the lowest among the big containers, 18. We want the greatest among the little things that fit into 2 and 9. That's what we're doing. Okay, that's a terrible method. Why do we do that method then if it's so terrible? Well, it does really show what a GCD is and then an LCM is. It's good. I would at some point show that. I think kids should see that at some point so they don't, because the other methods I'm going to give you are a little bit more magical. You know, just kind of move things around and poof, there's the answer, which is super nice, super easy, super powerful. But it doesn't give the feel. Because, you know, there's two things you're trying to do with math. You're trying to give good ways to get answers, but also a feel. Like, what is a GCD? Well, it's a container, which you really feel with this, right? A GCD, or actually a GCD is something that fits in, and what's an LCM? It's a container. So you get that feel because you painfully list them all out. So now, okay, so let's do the first one. GCD of 60 and 2200. 2200. Now this says by prime factorization. Okay, so we're going to do a new method this time. This method will be way better. It won't really give a feel, but it'll be way better at getting an answer. So what's the GCD of 6? So we wouldn't want to do this. Can you imagine taking 2,200? Just think with me. Watch how terrible. Don't write this down. But if you were to do it the way we just did it, you would have to take 2,200. What's the square root of that? Somebody have that? What's the square root of 2,200 for the limit? 46 something? Yeah, so you'd have to start with 1. Don't write this down. 2, which would be 1,100, I guess. 3, doesn't go in. 4 and 5, blah, blah, all the way to 46. And then write all those out. It would just be terrible. And I don't even want to think about doing the LCM. So anyway, the new method will be super powerful. Here we go. What you do is you take the 60 and you prime, right? Prime factorization. That means break it down like with a tree, factor tree. You've probably seen that before where you break it down to primes. I don't want all the divisors. I just want the primes. So what times what, 60?
2 and 30.
Yeah, you can do 2 and 30. I'm going to do 6 and 10. Whenever they end with a 0, I always just do 10, 100, 1,000. Those are easy numbers. But yeah, 2 and 30 would be fine. You know, whatever you want to do. There's any way will be fine. It'll all be the same in the end. 6 is 2 times 3. 10 is 2 times 5. So I've got the 60. 60 is 2 squared times 3 times 5. That's the primes, the building blocks of a 60. We good so far? Found the prime breakdown of the 60. Now, let's take the 2,200. Same thing. Now, notice it ends in 2 zeros. So what does that mean I can do right away? 22 times 100, right? Whenever a number ends with 1 0, it's times 10, or 2 zeros, it's times 100. That's just a quick way to start. You don't have to, but I think that'll make life easier for you. And then keep going. Break down the 22, break down the 100, till you can get the prime breakdown for the 2,200. Two times 11, 10 times 10. 2 and 11 are done. They're prime, right? They can't break down any further. 10, 2 times 5, those are done. 2 times 5, those are done. These were all done over here. So what does it mean then? How many 2's do we have? Looks like 3 of them. 2 to the third times 5 squared times, did I miss anything? I think I got it. 2 to the, check them off or something. 2 to the third, 2 5s, and 11. Yep, that's everything. All right, so there's the prime breakdown for the 2200. Now here's what you do. You bring it over, you bring the 60 over here. You go 60 is 2 squared times 3 times 5, and then you put the 2200 right below it. 2200 is 2 cubed, and then you line them up. Watch what I'm doing. I'm going to put the 5 under the other 5, and then the 11 off to the right. So you're lining up the various primes. Is that making sense so far? We're going to answer both the GCD and the LCM in like 5 seconds. We'll have them both. It's so powerful, this method. So far, so good? So you just write them down, line them up. See, I left a blank here because this didn't have any 3s. Line them up. Now, here's the deal. For LCM, or for GCD, let's do GCD first. For GCD, let me get this out of the way. For GCD, or GCF, same thing, you're trying to find the greatest amount they have in common. Remember what it is? Right? We're trying to find the biggest number that's smaller than them that fits into them both, right? I'm trying to find what number, what's the greatest number among the tiny numbers that fit into both of those as containers. That's the field, right? So what that's going to be, it turns out, is it's going to be the one that contains the most common primes. So in other words, the 60 has 2 2s, and the 2200 has 3 2s. How many 2s do they have in common? 2 2s. Are you with me? They both have 2 2s, don't they? They don't both have 3 2s. And they both have at least 1 2. Am I confusing you? So no, the most they both have is 2 2s. That's the most they have in common. So that's what you take. You take the greatest amount in common. How about when it comes to 3s? How many 3s do they have in common? None, because the bottom one doesn't have any 3s, right? Good so far? Is this making sense? So if I have a quarter and Simon doesn't have a quarter, then how many quarters do we have in common? None, right? You get an idea, right? So when we come to 5s, how many 5s do they have in common? What's the most they have in common? A single 5. And when it comes to 11s, how many 11s do they have in common? None. So that's it. Multiply that out. That's 4 times 5. 20 is the GCD. That quick we got the GCD, and we're going to have the LCM here in 5 seconds more. Well, I'll draw it out longer than 5 seconds, but LCM. So let me write what we just did for GCD before I go on. What did we do? If you wanted to write one quick rule about what we just did, what did I just do with all those powers? Lowest power for each prime. Didn't I just take the lowest power for each prime there? Right? When it came to 2s, I took 2 squared, the lower. When it came to 3s, I took the lower, which was none. When it came to 5s, I took the lower, which was just 1 5. When it came to 11s, I took the lower, which was none. I just took the lower amount of each prime because that's the greatest they have in common. You see. And now, for LCM, what do we want to do for LCM? For LCM, we want to do just the opposite. So we want a big thing that could contain both of them. Right? They have to fit in. It's going to be a bigger number, but it's going to be the lowest among the big containers. So it's the smallest container that's big enough to hold them both. That's a way to put it. Right? So it's a container that either one, well, can hold them both one at a time, not both together all at once. I'm not just going to add these up and, 2 to the 5th. I'm not going to add them up. But I want the smallest thing that will hold them, either one of them. So how many 2s do I need? If this one has 3 2s and that one has 2 2s and you want to contain either one of them, how many 2s do you need? 2 to the 3rd, the bigger amount. Does that make sense? 2 to the 3rd is the lowest amount that would contain either one. Why don't we just, you might say, I would wonder, if I was you, I'd be going, why don't we just add them, like 2 to the 5th? That would hold them both, right? That'd be, yeah, we don't want to hold them both at the same time. That would hold them both at the same time. That's true. But that's not what we're doing with LCM. With LCM, we're finding one container that either one at a time could fit into. So the lowest amount, the lowest thing that would hold either one is 2 to the 3rd. How about when it comes to 3s? What's the lowest amount of 3s we need to hold either one? the single 3, because we need a 3, because that 60 up here has a 3, and if we're going to contain him, we got to have room for that 3. When it comes to the 5s, how many 5s do we need to be able to hold either one? Yeah, 2. See how we're just taking the highest power every time? It's just highest power for each prime. We didn't finish. 11s. How many 11s? We need a single 11, don't we? And we're done. And then I don't know what that number. Somebody have a calculator. What is 2 to the 3rd times 3 times 5? It's just gigantic. 6,600. Thank you. And we're done. Would have been terrible with the other method. Everybody see that? Does that make sense? What's kind of funny? You know, this is always how I encourage people to memorize it. The greatest common divisor, you take the lowest, and the least common multiple, you take the highest. It's like backwards, but it's true, isn't it? Because it's primes. See the power of primes? If you deal with primes, things get way easier. Primes are the way to handle difficult questions with numbers. Questions on that one? That good? So I actually did GCD and LCM both. We're done. Let's do this one. So the first thing you need to do by prime factorization, we certainly wouldn't want to do it by the other way. By prime factorization. So take each of those and break them down, right? So take that 96 and use your calculator. Do a factor tree. Break it down to primes. Double check when you've got it. Like just multiply the primes out because you don't want to mess up. One little mistake and throws everything off. So break down the 96. Break down the 1764. And then break down the 630. So I'll jump in with you. When I look at big numbers like 96, I just start with 2. You know, I don't know what goes in there. Just use your calculator. So I got 2 to the 5th times 3 for the first one. Did you guys get that? Do that next one. What's up with 4? Am I doing that right? What's up with 441?
It's 9 and 49.
Oh, okay. Oh, yeah, because it adds to be 9, huh? 441. So 9 and 49, you said? 7, 3, 3. So we get 2 squared. 2 squared, 3 squared, 7 squared. Did y'all get that? That middle one. All right, so we good. So now we can line things up. I'll go to a fresh screen, but make sure you got those right. So go ahead if you've got that. Or let me know if I made any mistakes. I think I've got it right. Double check you've got it right. So we all get in there. So line everything up like that, right? And then find the GCD. So remember the memory device? You're finding the greatest amount they have in common. Greatest amount in common. So what's the greatest number of 2s they have in common?
1.
Yeah, just a single 2, right? No, that's the greatest amount they have in common.
Yeah. Okay.
Does that make sense? It's the lowest number.
The lowest power.
Yeah. The greatest amount of 2s that they all have is a single 2. Right? Because one of them only has a single 2. What's the greatest amount of 3s they all have? Just a single 3. What's the greatest amount of 5s that they all share in common? None, because a couple of them have none. What's the greatest amount of 7s they all have? None again. It's just 6. 2 times 3 is 6. The GCD is just 6. That's the biggest number that'll divide evenly into all of them. Let me pause there for a minute. Do you see that? Is that making sense? So we're just taking, I take the lowest amount of 2's, a single 2, the lowest amount of 3's, a single 3, the lowest amount of 5's, which is no 5's, the lowest amount of 7's, which is no 7's. But that is the greatest amount in common. That's the main thing I want you to see logically. Do you see that? Right? Again, let me again reason it. If person A has 2 coins, person B has 3 coins, and person C has, 5 coins or whatever, what's the greatest amount they have in common? If they said, hey, how many, you're going to share equally, so how many do you all have in common? 2, right? It's the lowest number. That's how many they have in common. They all have at least 2, don't they? Okay, good? All right, now LCM. LCM, now what's that? That's going to be a container that can contain any of them, but the smallest container. So how many 2's do I need if I'm going to build a container big enough to hold any of them? 2 to the 5th. If it's going to be able, if any of them are going to be able to fit into it, that's what a least common multiple is. It's a container. And how many 3's do I need if the container has got to be able to hold any one of them? 3 squared. So you're just taking the highest of everything, aren't you? How many 5's do I need if it's got to contain any of them? A single 5. How many 7's do I need? 2 7's. Whatever that is. Some big number. Somebody got that? 70,000? 500? 560? 7560?
I think I multiplied it wrong because I got all 2 numbers, but my ending number was wrong. But I think I multiplied it wrong.
Did anybody else get that same number? Yeah. Okay, looks good. Thank you.
I just did it.
Are we good there? Is that making sense how to do that? So that LCM again is the lowest container, right? It's the smallest container. If you're gonna hold any of these, it's the container small. It's the smallest container that any of them could fit into, right? So you've got to have 5 2's. Students are getting younger and younger. And 2 3's, a 5, right? Because I gotta take the highest of each of these if it's gonna contain them, don't I? We good? Questions on that one? All right, that method's way more powerful, right? Can you imagine trying to find that answer with the other method? Would have been terrible. All right, so primes. You see the power of primes? Primes, when you do primes, you find the building blocks of the numbers. It's like doing the periodic chart or something, You find what things are made out of, and then you can do amazing things like they do with chemistry when they break it down to the elements and all that stuff. Okay, so number 4. The product of 2 numbers is 13, 13, and their GCD is 13. Find their LCM. Well, basically, there's a simple formula that you need to know about. In fact, maybe I could just show it. What if I showed it back over here? Oh, that's a terrible one. What if I did an easy one? Well, whatever. Here it is. The GCD times the LCM is the first number times the second number. That'll always be the case. The GCD times the LCM will always equal the first number times the second number, which is kind of surprising. So it's like a little formula. You're going to definitely want to have it on your 3x5 card for our exam week from Monday. So what am I talking about? Well, basically, we're going to use that formula. And what are they telling me? They're telling me the product of 2 numbers is 13, 13. What does that mean, the product? What does product mean? Multiplication, huh? So they're telling me this right here. They're telling me they multiplied the 2 numbers, and they got 13, 13. The product. So I don't even know what the 2 numbers are. They're not telling me. They're just saying, hey, whatever those numbers are, we multiplied them. The product was 13, 13. And they're saying the GCD, that's 13. So put that in over here. That's 13. And they're saying, hey, what's the LCM? So I just took that little formula, GCD times LCM. They gave me GCD as 13. I don't know the LCM. That's like a big X. You know, it's like an algebra equation. Just pretend that LCM is a big X. And then they told me the product, the two numbers multiplied, even though I don't know what the two numbers are. They don't care. I don't care. Sure. And then they want to know, can you tell me the LCM? So how do I give them the LCM? Exactly. It's like a little algebra equation. This is like a big X, kind of. Right? 13 times X, just divide by the 13. Boom. Hit. So the LCM, hit the buttons on your calculator and... Oh, I know. Wait, I know. Wait, 101. Right? Because it's 1,300 and 13, right? So it's 13 times 100 and yeah. So 101. Does that make sense? Want to try it on number 5? See, on number 5, they're giving you the GCD. Oh, wait, I don't have time for that. I need to show you one other thing. So it's the same thing. Number 5 be the same thing, same formula. They're just giving you both one of the numbers. They're giving you the GCD and the LCM. They're giving you the two things on the left side. And they're giving you one of the numbers on the right. And then you solve for the other like an X. Same thing. I'm going to move on. So with our last 2 minutes here, they want me to find the GCD using a method called the Euclidean Algorithm. What that means is basically long divide smaller into bigger. So long divide smaller into bigger. And then rotate. I'll show you. Here we go. So let's take 3, 2, 3 into 2, 4, 1, 9. And I have no idea. Do y'all have a calculator? What is 2419 divided by 3, 2, 3? You get some whole, and all I need is the whole number part. I don't care about the decimal. 24? 7?
Yeah.
Is that what it is? Okay. So 7. 7 point whatever. Right? It doesn't go in clean, does it? No. So then just write the whole number 7. It doesn't matter where you write it. And then clear your screen and go 7 times 323. Just use your calculator. 7 times 323. What do we get? 2261. Okay, and then just subtract on your calculator. Or by hand, however you want. 158. So I just did the first step. Or I did the long division. And this is a remainder. We good so far? It went in 7 times with a remainder. So that's just normal long division, just using our calculator to help. Now here's the trick. Everybody watching? Do some sleight of hand. They rotate. This goes up here. And this guy's going to go in there. And we'll just forget about this guy. So the next step, the 158 will be on the outside. Let me scoot it over so we have room here. The 158 will be on the outside. And the 323 will be on the inside. And you go again. And we just keep doing this till we get a remainder of 0. And when we do, the minute you do, the answer is on the left side. Let's keep going. I'll show you. So how many times did I go? 2 times? That'd be 316, I think. 4, if I said, leaves the 7 remainder. Okay. I'm going kind of fast. I want to get this done for you. Then rotate. Again, you just do this weird rotation thing, which I know I haven't given any reasons why. It's kind of like magical. But I'd be glad to explain deeper reasons why in office hours. If you want to come by and talk about it. My office hours are after class Monday, Wednesday, every week. And then we do another one. Just keep rotating. So I just keep rotating every time. 7 goes in there. What is it, 20? 22. 22 or 21? 22? 22. Okay. 140, 154. Is that right?
Yeah.
Leaves 4. We good so far? Rotate. We're almost there. Rotate again. 4 goes there. 7 goes there. 4 goes into 7. How many times? 1 time. Remainder 3. This is just a crazy problem. They're not normally this long. Rotate 1 more time. 3 goes there. 4 goes there. 3 goes into 4 1 time. 1. This one just keeps going. Last step. Very last step is going to be the 1 goes there. The 3 goes there. 1 into 3. 3 times. Remainder 0. So where's my answer? It's actually this number right here on the left. It's just 1. The answer to all that is 1. But you see the process. Normally it's only like 2 or 3 long divisions. That's the worst case scenario there. So you just keep long dividing, rotate. Long divide, rotate. Long divide, rotate. Long divide, rotate. Once you get 0, the answer is on the left side. So there we go.